Hi, welcome back, kiddos, to our discussion about chemical reactions. Now, we're almost ready to predict our products, but before we predict products, we want to be able to develop some sort of classifying scheme into which we can divide the reactions we'll be studying. And there's, a variety of ways, and there is overlap in here, but we're going to streamline it to some of the most simple reactions that we'll be coming across. So we have 5 types of reactions that we ultimately want to be able to first classify and predict. Now, there's within those 5 types, or not really within those 5 types, another classification of those 5 types is whether or not those involve an exchange of electrons. Some will and some won't. So the answer is yes or no to this one. All right, predicting very complicated reactions that involve the exchange of electrons is beyond the scope of our conversation. But we do want to be aware of whether or not that's happening. For one, it builds up the picture for us of a relative rate of a chemical reaction. And it also helps us understand exactly what's happening down at the atomic level if we can look at what's going on with the electrons. Because at the heart of bonding and reactions are involving the changing of bonding lie electrons. Okay, so what we want to start discussing before we get into those 5 types are what are called oxidation reduction reactions, is kind of the full name. I don't know why we do it oxidation reduction when it's a full name, but then we call them redox reactions for short, reduction and oxidation. These are substances in which the reaction involves an exchange of electrons. Now we're going to be looking at simple ones, and primarily what we're going to be looking at are elements, either pure elements going into a compound or pure elements coming out of a compound. Pure elements all by themselves have a 0 oxidation number or charge. Whenever a substance is in a compound, with the exception of carbon, and we won't run across it, we'll find that they have a positive oxidation number. Now, this one here, I don't personally like the way we phrase this. All right, I like to talk about whether it's becoming more or less negative. So instead of saying more positive, I like to say less negative. Now, that may seem like a subtlety that isn't important, but I think it is, because what we're gaining and losing are negative electrons. So if it's less negative, it's due to a loss of electrons, and that process is called oxidation. If it's more negative, that must mean we're gaining those negative particles, and that's called a reduction. So I'll talk about things being either more negative or less negative. Okay, so that's why we call them redox. One is gaining electrons, one is losing electrons. Now remember, elements by themselves are pure. And a mnemonic device for remembering this is oil rig. Oxidation is loss, reduction is gain. So oxidation is loss of electrons, reduction is gain of electrons. And you won't have one without the other. Okay? So here are the 5 types that we will be studying. And a synthesis, to synthesize means to combine or put together. And so we're going to be looking for 2 reactants going to 1 product. And the ones you will have to predict will simply be formula writing. We'll put 2 elements together to form an ionic compound or a formula. If it's more complicated than that, you will have to classify it, but we'll give you what the product is. Okay, so a synthesis, we're going to talk about it as much like a marriage, put 2 things together. Decomp is 1 going to 2. And that's something, it's not the most pleasant analogy, but it works. That's something like a divorce. And what you'll be looking for is the fact that there will be only one reactant present. That will be your key indicator that it's a decomposition. Now, there's 2 types of replacements. Replacements are about switching partners. It's a switch of partners. And the issue with these is they're both 2 reactants, 2 products. 2 reactants, 2 products. The key distinguisher between single replacement and double replacement is that single replacement has an element and a compound going to an element and a compound, whereas double is compound plus compound goes to compound plus compound. Okay? And then we're going to be doing a very narrow category of combustion. Combustion involves the reaction of elements with oxygen. And so you'll see things like burned or combusted. And that means we're going to react with oxygen. It's the one time you will actually have to predict or supply a reactant as we're going. Now, the only ones we're going to be dealing with are either hydrocarbons or maybe we'll add an oxygen to it. There's a whole class of alcohols and so forth that have oxygen. The point is, if it's not your ane or your cycloanes, we'll give you the formula. So, but it will take carbons, hydrogens, and oxygen. And at your level, we're always going to be forming carbon dioxide gas and water. Okay? Incomplete combustion of hydrocarbons forms carbon monoxide, and that's why you get carbon monoxide poisoning occurring in some homes. We're going to take it completely to CO2. And so those are our 5 types that we want to be able to classify, and then we're going to be doing some degree of predicting with these. Not all of them, but some level of the most introductory predicting. Okay? So, Mimeo, why are you being fussy on me here? Okay, here we go. Now, this shows particle representations. IB in advanced placement is very big on being able to depict chemical processes as much as possible at the atomic level. And so we use symbols with letters, but sometimes we use particles. And we notice here we have the 2, and we know they're becoming 1 because it showed a bond. And so 2 becoming 1 is like a marriage or a synthesis. In this case, we have a bond, and that bond was broken. And when the bond is broken, we call that, as an analogy, a divorce. And so that would be our decomp. So this would be our synthesis. Now, in both of these, we have 2 and 2. 2 on both reactants and 2 products, but we can distinguish the single replacement from the double replacement because it shows elements, not bonded to anything. Whereas double, this should be, let me erase that and fix that. I was talking and my mind got ahead of us here. This would be double replacement. Double replacement involves compounds or maybe water, ionic compounds, acid, and single replacement will always have an element involved in it. Okay, and then this shows a combustion at, kind of a structural formula model. So that gives you an idea of our types. So let's take a look at how we would classify these. So we've got to be able to balance and classify and then ultimately predict. That's our goal. Now, first thing you want to do is count how many are on each side. I have 1 reactant, I have 2 products. That's the decomp. Here I have 2 and 2. So it's either a single replacement or a double replacement. And by the way, every once in a while you'll hear the word displacement instead of replacement. It's also called a metathesis reaction, but I can't say that one very well. Okay, so back to this. I call it single replacement. You'll see more details why when we predict. But do you notice that we have an element and on each side? So we have a compound plus an element and a compound plus an element. That makes that a single replacement. Okay, here we have two reactants and two products. Since it's compound plus compound, going to compound plus compound, that tells me it's the double replacement, not the single replacement. Here I have oxygen, CO2, and water. Hopefully that's pretty clearly a combustion. Okay, I've got two reactants, two products, so it's either single replacement or double replacement because we know it's not combustion because it doesn't have oxygen there. And since I have an element and a compound and a compound and an element, that's how I know it's my single replacement. Here we have two becoming one. That's that marriage or that synthesis we talked about. So, okay. I know that was a pretty quick overview of these. We're going to be doing lots of them and classifying them. So until our next video, this is, as always, signing off.